Aloha once again. This is part 5 of chapter 4. You all know I like to teach isomers by thinking about what's going to happen if we chlorinate a molecule. So let's imagine that we chlorinate bromocyclohexane. That is, we treat this molecule here, with chlorine, heat, and light. And this will indiscriminately place a chlorine at every position. And so I'd like you to work on telling me how many isomers are going to be formed in this particular case with bromocyclohexane. And I'll talk you through it. We can brominate at this position, in which case the chlorine will come to this axial position. That's one isomer. Bromine is bigger than chlorine, and so probably will have more steric interactions than chlorine. We can put a chlorine at the second position, and it can either be axial, that's the second isomer, or it could be equatorial, that's the third isomer. We could put a chlorine at carbon number 3, axial or equatorial. That brings us up to 5 isomers. We could put a chlorine here, axial, equatorial, bromochlorocyclohexane. So we have 1, 2, 3, 4, 5, 6, 7 separate compounds of formula bromochlorocyclohexane formed in this reaction. If we put the chlorine here or here, those are not new isomers because they're the same as putting it on this carbon. And putting a chlorine here or here does not form new isomers because this carbon is identical to this one. These are good problems for you to work on. I urge you to try the chlorination of bromocyclopentane and bromocyclobutane and see how many isomers you get. Draw them all out. Make sure you can draw cyclohexanes legibly, and make sure you can show clearly whether a substituent is axial or equatorial.